Good evening, ladies and gentlemen. Welcome to Colchester Filmmakers online technical talk on audio. This evening we have Marcel Glover, and please put your hands together virtually for Marcel.
Good evening. I'm going to talk a little about sound recording with a particular application to film. But let's start with sound itself. It's all around us. It's around us so often, so much, that we tend to ignore a lot of it. I don't know how many of you, like me, live next to a busy road, but you get used to the traffic noise and only notice it when there isn't any. However, nature thinks that being able to hear sound is very important because it comes at us from 360 degrees. Our ancestors needed to hear the saber-toothed tiger creeping up behind them. It's our 24/7 warning sense. It's the sound of the burglars that wakes you up and not the sight of them. And any of you that have taken first aid lessons will have been taught that your hearing is the last of your senses to switch off before you become completely unconscious or dead. So what is the physical nature of sound? What allows us to record it? And why did it take until 1877 to have a practical method of recording sound when photography was invented in 1839. Basically, sound is minute variations in air pressure. Now, around us is the atmosphere, and it presses on every part of our body at about 1,014 millibars, or 1.014 bar if you're an engineer. They like engineers like bar. The pressure in your car tire is roughly 2 bars, about 30 pounds a square inch. And now scientists have invented a teeny weeny little unit for very low pressures called the Pascal. There are 100,000 pascals in a bar. A pascal is defined scientifically as a force of 1 Newton over 1 square meter. Or if you like to think of it in simple terms, that's an apple squashed out until it's a yard square, roughly. So that's a very low pressure. But when you're a young person, the threshold of your hearing at 1,000 cycles, which just happens to be the frequency that a baby cries at, your threshold is 20 micropascals. So that's 20 millionths of something that's at 100,000th of the pressure that's all around you. That's minute. The threshold of hearing, acousticians, people who deal in sound, call that 0 dB, 0 decibels. I will come to decibels in a minute. The threshold of pain at the other end of your hearing range is about 120 decibels, which is a dynamic range of about 1,000,000 to 1. Now, to put that in perspective for picture people, the CMOS sensor on my still camera boasts an exposure range of 13 stops. Now, 2 to the 13th power is 8,192 to 1. you compare that to 1,000,000 to 1, you'll see that sound has a terrific dynamic range. Now, let's deal with decibels, which is a unit often used in the measurement of sound. And those of you that like looking at technical specifications will find decibels used everywhere, not just for sound, but for signal levels as well. There is a definition of a decibel as being 20 times the logarithm to the base 10 of the ratio of sound. And this is an important thing to bear in mind, that a decibel is not a thing like a foot. It's a ratio. So when you start talking about decibels, you need to know what 0 is. And if any snake oil salesman comes and tries to bluff you with decibels, just ask them what their reference level is. If they can't tell you, it's rubbish. So a whisper is, in acoustic terms, it's about 30 decibels, which is 31 times as loud as your threshold of hearing. A normal conversation is about 55 decibels, or 562 times as loud. And if you're inside an underground train, at some places in your journey, it's really very noisy. That can be as much as 100 decibels, which is 100,000 times louder. Now you'll notice the interesting thing is that this decibel scale is not linear, so it allows you to compare things that are very widely spaced apart with just a few numbers. And if you, as I say, if you look at equipment specifications, you will often see output levels of equipment expressed in decibels. And what you need to know is what the 0 level is. So you will often see outputs quoted as dBV, and that tells you immediately that the reference level is 1 volt RMS. If you see dBu or dBm, that refers to line level, which is a very old-fashioned term from the days of telephone technology. And that's the voltage that dissipates a milliwatt in a load of 600 ohms. Or if you want a proper voltage measurement, it's 775 millivolts. You can use decibels to express gains in amplifiers with the added benefit that whereas if you have chains of amplifiers, you start to need to multiply their amplification factors to get to the overall value, with decibels, you just add them up. So that's your physics and your maths done. Let's think about the actual practical aspects of sound recording. You basically need a chain of 3 links. You need, first of all, to turn those teeny-weeny pressure variations into an electrical signal, which is done in your microphone. It's what engineers call a transducer. It takes mechanical energy in and gives you electrical energy out. And then, having got an electrical signal, you need a recorder to store your signal in some sort of fashion that allows you to reproduce it at any time you like and to manipulate it in the way of filtering or chopping bits out. And the bit in the middle, which shouldn't be forgotten, is your connection between your microphone and the recorder, which will either be a piece of wire or a radio link. So, microphones, how do they work? Basically two principles. There are others, but they're old-fashioned and you needn't worry about those. The two principles are the dynamic microphone and capacitor microphones. The one feature they have in common, of course, is a diaphragm to collect the variations in sound pressure. But the dynamic mic moves a conductor inside a magnetic field to generate a signal. The conductor may be a coil, or in the case of a ribbon microphone, is a little piece of aluminium foil held in a gap between two magnets. So let's have a look inside a dynamic microphone. Here is the movement of a dead microphone that I have butchered up this afternoon, so you can see inside it. You'll notice, if you can see carefully, I don't know whether the camera can capture this, there's a clear plastic diaphragm. It has little folds in it to stiffen it up. And right in the middle is a very small coil of copper wire. Can you all see that? That's basically like a loudspeaker, except in reverse. The sound goes in and the electricity comes out. Now, dynamic microphones come in quite a wide range of shapes and sizes. Let's have a look at a few. So there are four examples of dynamic microphones. This one, you'll find a lot of these about. This is a Shure 58. They are really no good for sound for films. They're designed for pop singers to shove down the back of their throats until it hits the waggly bit at the back and then shout into it. It means they're not susceptible to feedback from speakers, but if you're trying to record the sound of an actor 10, 12, 15 feet away, no good. That's another musician-style microphone. You could use something like that to record conversation in a room. It's designed to be used at a greater distance. That again is a musical instrument microphone. This is an AKG D224. It's actually a dual capsule microphone. The high frequencies go in the end at the front where the diaphragm is and the grid. And there is actually another capsule in the back that handles the low frequencies. And you can cut out the low frequencies with this switch ring at the base, which gives you a limited amount of up to 12 dB, there's those dBs again, of attenuation at 750 cycles a second. Ribbon microphones are very delicate. By and large, they're not much use for film work unless you're working inside. This is the classic so-called Beatles ribbon microphone. They are very delicate. If you blow into them, you can ruin them completely and need to fit a new ribbon. The only thing you might ever want to use in the way of a ribbon microphone for film work is if you want to record a voiceover in the middle of a steel rolling mill, and that's one of these lip ribbons. You may have seen these used by sports commentators. They're shoved right against your top lip on that bar, like so. And you have little screens on the top so that when you snort through your nose, it's kept out of the ribbon. And likewise, in the front, you will also see another screen. I think it basically is a spit screen. But you can use one of these outside in a howling gale, and you will still get a reasonably good signal. But it's a very specialist microphone. The other way that you can have a microphone work is called a capacitor mic. They are more sensitive because instead of having a little coil, they just have a diaphragm which is placed very close to a back plate, and you apply a voltage across them. So you've got two conductors spaced by an insulating layer of air. And when the sound modulates, moves the diaphragm, you get a change in the current across the polarizing voltage, very, very small. If you like to imagine two boats moored either side of a big river. One boat is full of randy young men. The other boat is full of ladies in a similar sort of condition. But they're separated by the river. If you undo the mooring lines and allow the boats to get closer together, eventually someone is cocky enough to think, I can swim across there into the other boat. And the closer you bring the boats, the more people start jumping in the water and swimming across. So if you record the rate of people jumping into the river to swim across, that gives you a measurement of the movement of the boats, how far apart they are. Likewise, if you start hauling in on your line and you move the boats further apart, the number of swimmers gradually decreases. So that's how your condenser mic works. As I say, with only the diaphragm to vibrate, they are very sensitive, but they do require a polarizing voltage for the plates of the capacitor, and their signal is so weak that it has to be amplified in the microphone itself to give you a strong enough signal to send to the recorder, whereas your dynamic microphone generates its own voltage. There is a class of so-called capacitor mic these days that doesn't need a polarizing voltage. They're called electrets because the charge is actually built in during the manufacturing process to the plastic diaphragm. So they are permanently charged. The early designs of electret mics tended to lose their charge and therefore their sensitivity with age, but the modern ones are now much better. So let's have a look at some capacitor microphones. This is quite typical of capacitor microphones. There's the capsule that is just the condenser, and that contains the amplifier. This one is this capsule is what they call a cardioid shape, which means it picks up sound mostly from the front and is dead down the back end. So your sound pickup pattern is in the shape of a heart. But because this bit is detachable, you can get other capsules which are omnidirectional, so their pickup pattern is like a ball. And you can get other capsules that are hypercardioid, so they're a very much narrower cardioid, heart shape, but they usually have a lobe at the back where they will pick up. So they give you a tighter pattern at the expense of some sensitivity at the back. And if I open this little box, that's a hypercardioid capsule that fits the same amplifier. This is an AKG 451. Now, if you're going to buy second-hand microphones, you need to be aware that this is an old style 451. The modern ones that you buy and will see on eBay are probably electret designs and don't have detachable capsules. But they do have an extra switch. This one has a bass cut switch, which is handy if you're working in windy conditions, or if you have someone with a very boomy voice, you can actually filter out some of the low frequencies.
Lionel is asking, are capacitor mics also known as condenser mics?
Yes, they are indeed. A capacitor and a condenser are just different words for electrically exactly the same thing. These little lavalier mics, these are usually electret designs. This is so tiny, you probably have difficulty in seeing that. Can you see that? Tiny little thing, it's about 1/8 of an inch in diameter. That is a microphone. Difficult to believe how small they can make things these days. So, I don't know whether you have any gardeners in the film club, but if you ask a gardener, he will tell you there are basically just two types of vegetation. One type is terribly fragile. It germinates badly. It's very fussy on the amount of sunshine and rain it gets and what sort of soil it grows in. That type of vegetation is called plants. The other type of vegetation you get in your garden is robust. It reproduces profusely. It's completely immune to the effects of rain and sun. It'll grow in the most appalling soils, and they're called weeds. Now, sound is very much the same when you're making a film. There is weak, feeble, blown away in the wind sounds. They're called dialogue. The robust sounds that come at you from all directions at huge volume is called noise. So our aim in recording sound for video is to try and maximize the dialogue and minimize the noise. So, how do we go about it? Well, one of the easiest ways of reducing noise is not to film in a noisy location. Who was it who said location, location, location? He must have been a sound engineer. Anybody that's tried to record sound will know that the location is chosen by picture people. They go like that and say, "Oh, that's wonderful. I really like that." They can't see behind them the motorway, and by using the right focal length of lens, you can't see that funny row of lights at the end of the airport runway. And that row of trees screens the railway marshalling yard. Great, lovely picture for the sound man. He really wants to shoot himself because the noise is going to come from all directions. So please, picture people, choose somewhere quiet. Telephoto lenses. Yeah, lovely. You can do that. Can you do that with a microphone? To a limited extent. Let me introduce this beast, commonly known as a shotgun mic, principally because the earlier models were very much longer. I'll show you an old-fashioned dynamic one. A shotgun microphone. How do they cut out all the noise? Well, they don't cut all of it out, I'm afraid, but they can cut some of it down. You'll notice a grid in the end, just like you saw in this microphone. But down the side, they have a row of slits. So sounds coming from the front come down the tube into the capsule at the back. Fine, no problem. Sound that comes from the side has to squeeze its way through each of those little slits in the side of the tube. And in doing so, it gets slightly delayed. And so instead of going whoosh down the middle, it gets into a sort of a jumble. And it attenuates itself. It can't rush down the tube. It just circulates around inside the tube and gets lost. So they really are a godsend to the sound recordists. But you still have some problems with wind. How many of you have had your beautiful film ripped to shreds for wind noise on your soundtrack? You obviously haven't spent enough money on a windshield. This device is probably the most important part of your kit. You can spend easily over £1,000 on a microphone like that. You can spend several £1,000s on a recorder. But if you cheat on your windshield, you'll get rumbly sound. Now let's have a look inside one. First of all, what some people call the dead cat. What do you think of it so far? Rubbish. Essential piece of kit in high wind, because it breaks up the flow of air that's going to cause your noise. Inside that we have the basket. You can see why it's called a basket. It's a plastic grid with a very thin nylon mesh lining, a bit like a stocking. It has a cap that goes on the end. You can use these indoors. If there are, you can sometimes even use them outdoors if there's just a very light breeze blowing. They say that you will lose a bit of high frequency by putting the fur on. But of course, when you get old, you lose your high frequencies anyway. So you may not need to worry about that too much. Then inside the basket you have your suspension. Because the snag with microphones is that they will not only pick up sound from the air, from your actors, they will pick up the sound of actually handling the microphone itself. So what we do is to put it in a suspension. Clips in. This is the latest style Rycote. It's a lyre suspension. As you see, you can wave it about and it just gently waves to and fro and doesn't pick up the sound that's coming from the handle. One thing you need to be aware of is you need a very small, I don't know whether I've got one here, a very flexible cable to actually come out of the back of the microphone, and you need to pay particular attention to the cable grip to make sure it does get a good hold of the cable, because if the cable moves inside the grip, you will get again noise transmitted from the cable knocking against the plug, gets into the microphone, and you get these random knocking noises. So these are, say, the new one of these is quite expensive. You're looking at somewhere probably about £300 for a decent Rycote system. But as I say, if you want quiet sound, it's more important to put your money into your windshield than your microphone. If, however, you really are so poor that you can't afford to buy a Rycote, even second-hand, if you're handy with tools, you can make one. Here is one I made earlier, a lot earlier, when I was poor and couldn't afford a Rycote. You nip off to Franklin's and buy yourself some fur fabric and sew yourself up a dead cat. Actually, I was very naughty when I made this. I don't know whether you can see its little teddy bear eyes in there. Sometimes when you're interviewing, people will suddenly spot these, and then you watch them try and suppress a smile. It's very difficult. But that's your dead cat. Your basket is basically a bit of 4-inch soil pipe, which you drill some holes in and then cut the apertures out with a jigsaw. The ends are just bird baskets. Again, you get these from the builder's merchant. This one appears to have suffered from being left in the attic for too long. And a piece of very flimsy wire and a socket. And that's it. Quite easy to make. For suspensions, you can get some thin shock cord or elastic and tie some loops, crisscrossing loops through the center, and that will hold your microphone perfectly satisfactorily to give it the shock suspension. Because I'm an engineer, I made something fancy out of aluminium for this one, but you needn't quite go to that sort of expensive labour. So that's keeping noise out. What about getting the signal louder? Well, that's nice if you can do it. How can you do it? You move the microphone closer, in which case you need a pole. This is quite a small one, suitable for indoor use, carbon fibre. This is a Panamike one. They're made by many, many different people. You can find them on eBay, sometimes at quite sensible prices. If you're buying second-hand, it's nice if you can actually go and see what sort of condition they're in, because you need them to slide smoothly and quietly. You need the joints to be firm so that they don't change when you wave them about. And some that you get with a cable built in. Give it a shake and see if your cable rattles, because if it does, you're liable to get noise again transmitted into your microphone when you move the thing. So booming is a skill in itself. It's often the way sound recordists start their career, is by being a boom operator. Basically, try not to adopt an awkward stance when you're doing it. Let me put a microphone on the top here. There are plenty of YouTube videos all about the various skills of filming, where you can see this sort of thing demonstrated. You've got to keep it out of the picture. One thing you'll learn very quickly when you start recording sound is that picture people are very sensitive. If your microphone appears in their picture, they will go absolutely ballistic and tell you in no uncertain terms that you're ruining their fine composition with that horrible thing that's coming into the picture. So you sometimes have to adopt rather strange positions to get your microphone out of the picture. Now, you also learn fairly quickly that you need to be aware of boom shadow, which is, although your microphone may be out of the picture, its shadow isn't. So if your son is over there, you stand downstream of the camera. So your shadow, or the shadow of your microphone, is thrown out of the frame. Likewise, when you get lighting from above, if you put your microphone up, it will cast a shadow. So your only other alternative is to put your microphone below the frame. This is sometimes frowned upon as being not as good, but whatever works is the best solution. If you're working outside, you find that miking from below tends to pick up birds and aeroplanes. Of course, if you're miking from above, you can pick up feet if they're noisy. You just have to make it up as you go along with your booming as to where you place your microphone. But the closer you can get it to the talent, the better your signal will be compared to the noise. We'll have a look at a bigger boom. These come in various lengths. That short one was suitable for outside work. This is one for inside work, rather. This is one that's more suitable for outside work. This is probably going to go way beyond the range of that lens. Let me go down the back. So that's what, about 12 feet? They make them even bigger than that. I have some booms that will go right from the back of the warehouse, right over the end of the gantry we're on. This style of boom is not for hand holding. It's a trick thing for putting on a stand with counterweights. So that's booming. And it's about time we had a cup of tea, is it not? 2 minutes?
We can wrap it. Yes, I think it's a good, appropriate time to possibly grab a cuppa and visit the little boy's room or girl's room or non-binary room. And yes, we will be back at 9.
Splendid.
Short and curlies for that entire thing.
What?
It looked like I thought it looked. No one chatted. Lionel did ask about capacitors and condensers, and that was it. And then it went absolutely silent. They've all fallen asleep. They're all watching.
Yeah, that's more like it.
Silent Lionel went, "This is really what do you say? This is brilliant stuff. Oh, I'm loving it." So yeah, there you go. I've got smooth as well for my. Yeah, I mean, I tried to do the shadow on the trailer. That didn't actually work. I just got a picture of the table and you couldn't actually see the shadow. Yeah, because I was wondering if you were going to look for the sun.
Yeah. Well, I mean, it's you won't get much in lighting like this. It's
Okay, ladies and gentlemen, we've finished our tea here, and we were suitably refreshed, and we're now back to Marcel and his sound.
Right, I was talking before the break about booming. Now, if you're making films in a group rather than on your own, it's really nice to have a boom operator, because trying to get your microphone close to the edge of the frame but not in it requires quite a bit of attention. And if you're trying to operate your recorder as well as booming, you find you haven't got enough attention or enough hands to really do the job properly. So you have to keep your boom a bit further, your microphone a bit further away from the edge of the frame than you would really like to. So that's a point to be borne in mind. Get a boom op. Now, still on the subject of getting the microphone close to your sound source, what about putting the microphone on your sound source? That's why they make these teeny-weeny lavalier mics, or as the Americans call them, lavaliers. This is quite a common model. Let me put this where you can just about see it. This is the Sanken COS 11. Wonderful little mics. If you're a bit more hard up, you can get the good old Tram TR50. There's your Tram TR50. As you see, the Tram is what they call a side-firing mic, and the COS 11 is an end-fire. So when you're attaching them to your... I better not do that because there's another one there. When you're attaching them to your subject, the Tram faces outwards. This is going to be difficult as it's black on black. This little thing you can thread through buttonholes and that sort of thing. As well as your microphones, you will need lots and lots of accessories. People love accessories. So you end up not only with your microphone, but with a little pot of all sorts of clips. And windshields. There's a little furring. There is a tiny little basket. And then there are little foam devices for keeping the wind out. If you look at news footage, you will often see these things, because it doesn't matter in news whether your wind gag is seen, but if you're doing costume drama, these things are just too big. I think you've had a lecture before by one of our members on hiding microphones, so I won't go into too much depth to repeat what he's told you, but it's quite a tricky thing to do to keep them out of the picture, because you never know quite what the director is going to have in the way of close-in shots that are going to pick them up. Now, the snag of having a microphone attached to your actor is they tend to move about. So you need to have a link, which we haven't really spoken much about yet, between the recorder and the microphone. And we have to use a radio. This is a typical wireless transmitter with this little aerial. Again, keeping them out of sight is, on a costume do, is quite tricky. You also have to remember to try and keep the aerials away from the actor's body, because an actor is basically a big bag of water, as we all are really, and they will absorb radio frequencies, and you can get sudden dead spots where you lose your signal. That's why it's always handy, if you're using a radio mic, to also have a boom, just in case. The other alternative to using a radio is to use a small recorder. In fact, decent radios are quite expensive. It's often cheaper to use a small recorder like that than it is to use a good quality wireless. So that's another possibility for you. If you're doing something like an interview where your interviewee is static, you can buy a device like that, which converts your lavalier mic into a wired lavalier. Your wire, in theory, should be very much more reliable than your wireless connection. So it's always handy to have one or two of these little devices. This one is made by Ambient, German company. There are others available. So that's putting microphones on your actors. What you can also do, if you're using a set, is to plant microphones somewhere on the set. And you can use either a lavalier or almost any other sort of microphone that you can hide behind something. They're called plant mics. So let's think a bit more about radio, particularly when you're going to buy these things, probably second-hand, because the quality microphones, new, a radio system, you're looking at probably anywhere between £1,000 and £2,000 a channel for a really good quality mic, radio mic. But they are available on the second-hand market, but you have to be very careful when you buy second-hand that you get the right frequency, because only a limited number of frequencies are available to use. So when you're looking on eBay, see what the frequencies are. If someone is trying to sell you a radio mic and doesn't tell you the frequency, they're an idiot. Because that's the first thing you ask when you're buying a radio microphone is, what frequency does it work on? Our dear but greedy government some years ago decided to sell off one of the main frequency bands that was used by professional sound recordists, the band 69, about 800 and something megacycles. And so they suddenly became illegal to use, but they're still legal to use in certain countries abroad, and there are plenty of them about on the second-hand market. You have to be very, very careful to try and see if you've got a picture, to see and to look at the label and see if you can see what frequencies they work at. These are good old-fashioned VHF sets. The Pros, when Band 69 was made available, they moved away from the VHF frequencies in droves. So they're quite usable nowadays. There are about half a dozen frequencies at the bottom end of the VHF band that you can use license-free. The higher end of the VHF frequencies, which are about 170, 180 megs to 200 megacycles, there are some frequencies called shared frequencies. You have to buy a license. It's about £70 a year. But as long as nobody else is in the area using those frequencies, you can use them as and when you like. There are other frequencies in the VHF band which are what they call coordinated. So you buy a license for a particular day and a particular location, and in theory Ofcom will make sure that they don't sell a license for that frequency within so many miles of your location. So you have exclusive rights to use that frequency for the time that your license runs for. So that's radio mics. Let's have a look at the other form of connection between your recorder and your microphone, which is the cable. Again, you can spend thousands on your microphone and even more thousands on your recorder. And if you join one to the other with a bit of cheap Chinese cable and some crap knockoff connectors, you're going to get some rubbish results. It may just look like a piece of wire. It is just a piece of wire, but its quality is as important to your sound as the rest of your gear. Don't cheapskate on your cables. And look after them, because they are quite easily damaged. They get under your feet. They get under other people's feet. And they can become intermittent. Or you can lose one leg of the balanced connector, and that's half your signal gone if you suddenly become unbalanced. And if it's running open circuit, you can get hum introduced and all sorts of things. So this is screened twin cable. As you can see, this is about the standard size for cable, Van Dam cable, about 1/4 of an inch, or 6.25 millimeters for metric folk in diameter. Important features of your cable is that it's flexible and not stiff. You can buy this sort of stuff in low smoke sheathing that's really rather stiff. It's a bit of a menace. So flexibility is important. You can buy them in a range of colors. So if you're going to have them in shot, you can buy them in dropout blue or dropout green. Or you can buy them in the complete range of resistor color codes, so that you can quickly identify which channel is which if you're using a number of channels. Your connectors, well, that's another minefield. If you're into professional grade gear, the most common one you'll find for audio is the XLR connector. usually 3-pin. Nutric are the brand to go for. They're not that much more expensive than cheap Chinese, but they're made very much better. Silver-plated contacts, or if you pay a bit extra, gold, which doesn't tarnish to the same sort of extent that the silver will. You can buy cables ready-made, or if you're a reasonably dab hand with a soldering iron, you can make your own. But they are a vital part of your chain. Don't cheat. Right. Recorders. What do you record on? Well, depends on your budget. You've seen the little Tascams. There are little Zooms. And there are others. The Niagara 7, top of the range, about £3,000 new. I didn't buy it new. The difference between one of these and one of those is basically down to the quality of the microphone preamp. And a poor microphone preamp is likely to make your signal noisy. Frequently, the very small connectors will use recorders will use very small connectors, which are very fiddly and very fragile, whereas your professional machine uses good old-fashioned standard XLRs, as you see, for the input and the output. What you also get with the professional machine is more facilities such as timecode to synchronize your sound with the picture. It's a bit of a hangover from the days of good old-fashioned film, but it's often still used in professional circles for particularly we get multiple cameras and maybe even multiple recorders for making sure that you've got the right sound attached to the right picture. Your recording is usually captured on some sort of card. This has a built-in card and an external card, so that when the director calls cut, you can teach it to automatically send the sound from your main card to the external one, which is handy when you come to the end of the day and they want to get the rushes off quickly. You can just pull the card out to the side and say, there it is. You can download that right now. You don't get that with the smaller recorders. It's on one card and that's it. You also get often a wider choice of sample rates on the professional machines, sometimes up to 192 kilosamples. It's really not going to make that much difference to your quality of your sound, although if you're doing a lot of processing to the sound, you can get a quieter result after it's all been compressed and filtered and what have you. So if you're starting out in sound, 2 channels will give you quite a good choice of what you can do. I was recording with Henry the other week, 2 actors doing a show reel, and used a boom on one channel and the 2 radio mics on the other channel, because Shakespeare wrote his dialogue to be delivered one after the other. It's not like EastEnders where they're shouting over one another all the time. It's quite possible to do that, to have 2 mics feeding one channel with the aid of a mixer. And that's the next thing you want to consider if you're going up in capacity, is to get yourself a little mixer. This is a Sound Devices one. This is 5 channels in, 2 channels out. They make them down to 3 into 2. But 3 into 2 is also 3 into 1, so you can get 3 separate microphone signals going into one channel of your 2-channel machine, leaving you free to get another signal into the second channel. Very versatile piece of kit. It also, apart from its analog outputs, it has AES digital outputs, so you can send those directly into a recorder that has digital inputs. If you want more than that number of channels, then you have to start thinking of a multi-channel recorder. Let's go and find one. This beast is the Nagra 6. It has 4 microphone channels built in and 2 line channels. The 2 line channels are configurable either as analog inputs, or you can, at the touch of a button or several buttons, you can make them into digital stereo inputs. So you can have 8 channels of recording. This is why I bought the little Sound Devices mixer, because it now allows me to run 8 microphones into one recorder. Once you start getting several channels that need looking after, this is where you really start needing an assistant, particularly to operate the boom. If you'd looked at the one of the videos, I sent a link for a video called Off Fleek. If you look at its first scene in the room with 4 characters around a table, for that I was using 4 radio mics and a boom. That's about as much as you can really handle on your own. You get more channels than that, and you really do need an assistant. But this is paired up, as you see, with 4 radio receivers. It also has, or would have if I hadn't unclipped it, it has a transmitter. In fact, 2 transmitters. You can, on this transmitter, you can send time code to your camera position. And with this, you can send a scratch soundtrack to your camera position. So I have this little box. which you hang off the tripod, which has your time code receiver and your audio receiver. So you have the maximum amount of opportunity for people to synchronize the sound and the picture. I find that picture people don't really care very much about synchronizing the sound. It's difficult enough to try and get them to set the real-time clock to be the same as the sound recorder's clock. But it does make a difference to the editor, who has files and files and files of data, and has to try and match the right sound to the right picture. So that's the big recorder. It's if you're going to use this all day, it gets very heavy, whereas you can use the small one around your neck. This one, don't even go there. What you need is what every good sound recordist is wearing, is a harness. This one is by Portabrace. You tend to look a bit like a parachutist. But believe you me, it saves your back no end of wear and tear. So if you uncouple the belt, somewhere about here, we have some carabiners. So, this is your setup all day. Wearing this, or at least until dinner time is called. It has useful features, such as this handy hook for your headphones. That's another thing you'll need to buy, is a decent set of headphones. When you're choosing your phones, you need to make sure they are of the solid back variety. So many hi-fi phones these days are open-backed. Again, there are many schools of thought as to which is the best headphone to use. It's whatever you find comfortable. These are Sony phones. The Sony MDR 7506. There are plenty of these around second-hand. These are the good old Bayer DT48s. Sound quality is good. They are built like a Panzer. They also weigh a bit like a Panzer and about as comfortable to wear over long periods. So you have to choose very carefully whether you go for comfort or performance, like a lot of things. So, where do you go next from here? Well, we won't go there tonight, because that's cart-based systems, where you have a little thing like a shopping trolley or a magliner. If you're into really professional high-end carts, it's a completely different field altogether. So, time for questions, I think, as we have half an hour.
Silence. Came the reply.
Silence. Good heavens.
I hope they're still there.
They've fallen asleep. Too much physics and maths.
Is everything all right out there in the rest of the world?
No. No questions.
No. I think you may have informed our lot to the brim. They're not questioning anything.
They're not?
No, it doesn't appear so. It's either that or chat has completely broken down and I'm not getting
that is a possibility.
But, we can leave it for a few more minutes, a few seconds, shall I say. No one has any questions?
No one has any questions.
No. Could we have a response from the chat just to make sure that is still working? I think, Miss Al, you have absolutely covered everything.
There are lots more things I could say about sound, which I won't do tonight. But I would say when this wretched virus thing is all over, if somebody would like some sort of workshop on things like stereo recording techniques, or just to be able to handle the equipment, then I'm sure we could arrange some sort of little workshops for a small number of people.
Okay, we've just been informed there is a little problem with the chat. It appears to be delayed. I'm not getting any kind of update on the chat here, so there probably has been a few questions. I'm not sure if they're going to be sound related, but we'll see if we can get this to work again. I'll just refresh the page, a bit like turning it off and on again. Here we go. John Howden asks, balance cable, it's transmitting both positive and negative signals. Is that a good thing?
Balanced lines are wonderful. Because they reduce induced hum. If you're working anywhere near mains cable, then definitely go for balanced lines.
Henry asks, what's your favourite mic you currently use, say for general run and gun situations?
Is the one I used most commonly would be the Sennheiser MKH 416. Or for stereo use, I've got an MKH 418S, which is a mid-side microphone. They have a number of advantages in that they're what they call an RF condenser mic. This is getting a bit deep into electronics, but basically they are much less affected by things like dampness than the conventional condenser microphones that run at very high impedance.
Thank you for that. Alex also asks, what's the difference between, or have we had this one before, what's the difference between shielded and balanced cable?
A shielded cable has an outer conductor, either in the form of a metal foil or a woven braided shield that helps to keep the hum out of your cables. Now, what's inside that shield can be anything. It can be one single conductor. It can be a pair of conductors. It can be sometimes a whole lot of screened pairs in the case of a multi-core cable. Can be anything. In the old days, for professional sound, which is most of the gear you see around here, anything up to 36 individual pairs of cables inside an overall screen. Now the balanced cable has two conductors, and the screen is considered to be 0 volts. It's connected to ground, and when the signal in one of the interior conductors is going positive, the other one is going negative. So you get a much bigger, you get twice as much signal as you do in a single-ended cable. And as I say, the chief delight is when they get to the end where there's usually a center tap transformer. Any hum that's coming down both wires cancels out.
Thank you. Ken, he's asking, there's lots of non-pros who seem to be using the 2.4 giga, I believe that is, 2.4G radio mics.
Yeah.
Have you used anything like this before? I've missed the, he missed the first part, so have you used anything like that sort of transfer?
The trouble with 2.4 gigacycles is there is just so much traffic using it. It's what a lot of Wi-Fi uses. So anywhere where you've got Wi-Fi signals, you do get a lot of interference. It's potluck as to how good your reception is.
Thank you. He also asks, can you give us some advice on lavaliers? I think he missed the beginning of the talk.
Lavaliers. Yes. Let me first make a horrible rustling noise while I take this this machine off.
Oh, I was going to say, is that getting heavy? Because you're asking all the questions with that great big lump round you. It shows how much...
No, this really is nothing. But when you're wearing it all day, you can actually come and feel the weight of it when you have a moment. You'll find it's not light, because there's also an 11 amp hour battery in the bottom of that. Lavalier mics, well, what to say about them? They're very, very small microphones. Usually they are omnidirectional, so it doesn't matter which way they face. They will pick up a picture. You could put it behind your collar and it would still pick something up. You can put it down on your chest. You can couple it to your clothing. But that's a whole minefield in itself, is trying to keep noise from coming up the cable, or to keep clothing from not rustling on the front of it. Because if I do this, you should be able to hear that. That's one of the disadvantages of the lavalier, is that it's prone to pick up noise. So That's why I would usually try and use both sorts of microphone. It also gives your editor a choice of sound perspective, which he may want to mix and match your boom, which gives you much more ambience of the surroundings. You can decide how much of that to mix in to match the visual perspective of the shot.
Pierre, or Peter Silk, has asked, do you record sound for the Foley to use?
Yeah, you can. You would probably use a different sort of microphone. For Foley, you can use almost anything that's to hand. But something like that, that's mostly an indoor studio microphone that has multiple switched polar patterns, very high quality. It's also got a pad for loud sounds, and it has filters to cut the bass out. But there's no reason why you shouldn't record your own Foley. It's an art in itself, of course, Foley. It's trying to find the right sound, not necessarily the sound that appears on the picture, or the sound of the objects that appear on the picture, but what sounds right. There are plenty of books and videos on YouTube for showing you the various techniques they use in Foley.
Well, we're coming to a close. We've got a final question from Paul.
Yes.
And he wants to know, where did it all begin? Where did you start in sound?
Where do you start in sound?
Or where did you start in sound?
Where did I start in sound? Well, I started in sound at my brother's christening. I was about 15, I think, when my brother was christened. And with my dad's old ferrograph and a crystal mic, which we haven't mentioned because they're so old hats that nobody uses them anymore, stuck near the font, I recorded that. And I've done a lot of music recording, choirs of various degrees of direness, and other music groups, but of course nobody plays music or sings anymore. It's sort of gradually died the death. I record a lot of oral history for Colchester Recalled. I spoke to a man who remembered seeing the parade for the relief of Mafeking, 1902 or thereabouts. He could remember that. I've recorded a man who went to work one day and his boss said, "Would you like to come out for a sail?" And in next to no time he was on the beaches at Dunkirk, picking people up off the beaches. I've done quite a lot of oral history and editing oral history. If you go on the internet and look for Mercury Voices, there's a set of 6 podcasts, I think, which were a project we made discussing various aspects of theatre in Colchester from the time in about 1900 and not very much, when the Theatre Royal burnt down, to the closing of the Mercury for its refurbishment. So I've been in sound a long time.
Well, that's a good point to wrap up. Well, we've asked all the questions that we thought we didn't have until I refreshed the screen and all the chat came back. On behalf of the club, I'll thank very much myself for your chat. at your talk on this and answering everyone's questions. I'm sure if there's any more probing questions they need to ask, they can email you, I'm sure.
They can, yeah.
Well, thank you very much. We'll do a virtual round of applause from everybody, if it will actually happen, but we're doing one here for you.
Thank you very much.